Okay, this video is about solving logarithmic equations using the properties that we know of logarithms and exponentials. Alright, so key things to remember. Remember this property. It says log base a of x. If that equals the log base a of y, meaning the bases are the same, then you can say that x equals y. Also, we said the natural log of x equals the natural log of y, meaning their bases are the same, right? Base of e. Then x equals y. These two properties are going to be very helpful as we solve logarithmic problems. Alright, so look at example 1. Log base 3 of 5x minus 1 equals the log base 3 of x plus 7. Well, the beautiful thing here is that we have log base 3 both sides of the equation. So basically they cancel each other out, and I have 5x minus 1 equals x plus 7. Hopefully we can solve this. So I subtract x. 4x minus 1 equals 7. Add 1 to both sides. 4x equals, that's a 1 by the way, and 8. So x is 2. Easy enough. Look at example 2 here. Log base 6 of 3x plus 14 minus the log base 6 of 5 equals the log base 6 of 2x. So thankfully, notice they're all the same bases. Okay. Also, what I want you to notice is there's a minus sign here on this side of the equal sign. Remember the quotient rule. The quotient rule said two things are being divided, you can separate them with a subtraction sign. So I'm going to condense this down, since they're the same base, to log base 6 of 3x plus 14 over 5. That's good old quotient rule at work, equals log base 6 of 2x. Now I look at the logs and their bases are the same, so they will cancel each other out per my property, and I'm left with this equation. I'll put that over 1, and I'm simply going to cross multiply this. So I get 10x equals 3x plus 14. Subtract 3x. So 7x equals 14. X equals 2. Alright, so we used quotient rule. We used the same base properties. Hopefully that helps simplify the problems. Alright, next example. The natural log of x equals 3. Well, how are you going to solve this? We need to get rid of the natural log part. So the way to do that is to make both sides of my equation the exponent with the same base. So what I want to do is get rid of the natural log. So what is the base of a natural log? It's an e. So what I'm going to do is e and raise it to the natural log of x equals e to the third power. And here's why. E raised to the natural log of anything, those will cancel out, and the x basically drops down, equals e to the third power. And I can type that into my calculator. E to the third power, when you type it in, is 20.086. And that's my problem. Next example. Keep trucking along here. Want to get the natural log of x alone, so I need to separate it out. Get rid of the 5 first by subtracting. So I have 2 natural logs of x equals -1. Divide by that 2. So I have the natural log of x equals -1/2. Now, just like we did on number 3, to get rid of the natural log, we're going to make e the base and make the natural log of x my exponent. What you do to one side, you have to do to the other. Natural log, e to the natural log of anything cancels out, x drops down. And then I type it into my calculator, e to the -1/2 power. And when you do that, you get 0.670. Number 5. I need to isolate the x, so I need to get it by itself. So let's look at this. First of all, let's get rid of this 2. Let's divide both sides by 2. That gives me the log base 5 of 3x equals 2. Now, what's unique about this problem is it's the log base 5. It's not the log base 10 or natural log. It's the log base 5. So I want to create the base that's going to cancel out the logarithm. So I need the bases to be the same. So I'm going to make my base a 5. So I'll do 5 raised to the power of the log base 5 of 3x equals 5 squared. So what happens is that 5 raised to the log base 5 will cancel out. The 3x drops down, and 5 squared we know is 25. Divide by 3, x will then be 8.333. Okay, so the thing about this one is that you have a different base, which means you're just going to create a different base when you create the exponents. Okay. What about this one? How to check for extraneous solutions. This comes back to that old rule of you can't take the log of a negative number. So we'll do that at the very end of the problem. We need to solve this first. All right, so notice the plus sign. That should trigger in your mind the product rule. Okay, good old product rule. And that says that these two things should be multiplied since the log and its bases are the same. So the log of 5x times x minus 1 equals 2. All right? Now, I need to get rid of the log, and the base of my log is 10, right? If it's a common log, the base is a 10. So I'm going to go 10 raised to the log of 5x times x minus 1 equals 10 squared. Same base on both sides. These cancel, so this 5x times x minus 1 drops, and 10 squared is 100. So now I solve it. 5x times x is 5x squared minus 5x equals 100. All right, so I bring the 100 over, subtract it out, and now I have a quadratic I can factor. First thing I want to do is factor it, reduce it down by taking a 5 out of each term. That gives me x squared minus x minus 20. This I can factor. Hopefully you're beginning to see this. X minus 5 times x plus 4. And if I solve that for x, x would be 5, x would be negative 4. All right, so here's my two solutions. I need to figure out, are they extraneous? So what I do is go back to my original problem. Okay, this is my checking station, I guess you want to call it. So first I'm going to check the 5. All right, so I say the log of 5 times 5 plus the log of 5 minus 1, does it equal 2? Well, 5 times 5 is 25. The log of 5 minus 4 is, or I'm sorry, 5 minus 1 is 4. Product rule says since these are added, I can really multiply 25 times 4. So really it's asking me, so log of 100, does it equal 2? Remember, what's the base of this log? That's really 10. So it's asking me, is 10 squared equal to 100? Yes. So 5 is a legitimate solution. All right, let's try the negative 4. Log of 5 times negative 4 plus log of negative 4 minus 1 equals 2. 5 minus 4 is 1. Oh no, I'm sorry, it's multiplied. 5 times negative 4 is negative 20 plus the log of negative 5 equals 2. All right, what you should notice is it's asking me to take the logarithm of negative numbers here. You can't do that. That's impossible. So this x is a negative 4 is an extraneous solution. Okay, so I only have one true solution to this problem. So sometimes you're going to have to check to see if both solutions work. Sometimes they both will, sometimes only one, and maybe not even none. So you do have to check that when it comes to logarithms. All right, for your whisk, I want you to solve this, and you should have one extraneous solution, and I want you to put that on the whisk for me. What's the extraneous solution to this problem? All right, good luck, and see you in class.